Specific heat definition. What's the definition of specific heat? Let me explain. You know Q equal to ms delta T, S equal to Q by M delta T. We derived in the previous class. Let's take one jar with big jar with hot water like 80 degree centigrade water, and two test tubes are fitted with retard stands, and the two test tubes are filled with oil and water. So the that both liquids are at 30 degree centigrade. That test tubes are fitted with 1 volt rubber cocks and mercury thermometers. So what happening in this activity? In the previous class we already discussed, but here, so the water in mercury level is rises rapidly in the oil than the water test tube. That means the here the rise in mercury level is more faster than the water. So this is we understand in the previous class. This is rise in temperature, rise in mercury level. In the next one is falling temperature or falling mercury level we can observe. What's the, this is most, this is the just opposite of this first activity. I mean reciprocal of the first activity, you know, this activity. In the second activity, you know, the both test tubes they are at 90 degree centigrade, 90 degree centigrade, but the jar, water with big jar is at 20 degree centigrade water. Then what happening now? The more, if the specific heat is more, it's rising and falling both are very slowly takes place. That means if the specific heat is high, the rate of rising or rate of falling in temperature is low. For same quantity of heat is supplied. Here in the first activity, the rise of mercury temperature is very low, very slowly takes place. But in the second one, the falling of temperature in the water is slowly takes place. This is very slowly comes down. That means here the water has more specific heat than the oil. This indicates, this is the reluctance. What's the reluctance? Unwilling to do, unwilling to rise or unwilling to fall. This is the reluctance of the substance change its temperature. So we can understand very clearly from this activity. Now specific heat value of some substances, let's explain. What's the specific heat of substances? You know, here some substances we are placing. One is lead specific heat in Celsius system and MK system. In Celsius system 0.031 and in MK system 130 joule per kg Kelvin, and in mercury 0.033 and 139, brass 0.092 380, zinc 0.093 391, copper 0.095 399, iron 0.115 483, glass 0.12 504, aluminum 0.21 882, kerosene oil 0.50 2100, ice 0.50 2100, water 1 calorie per gram degree centigrade, and 4180 joule per kg Kelvin. This is the specific heat of water here placed. So the seawater is different than ordinary water, 0.95 and 3900. These are the specific heats of the different materials like lead, mercury, brass, zinc, copper and so on. Students, you can understand what is the material and what's the specific heat. Next, let's why the specific heat different for different substances. Why the specific heat different for different substances? Take the two beakers and fill it with cold water and hot water, and place the pinch of food colors. What we are watching here, see in the hot water the pink color is becomes very rapidly than the cold water. Here the molecules are moving very randomly and fastly than the cold water. Here it becomes already pink color than the cold water. This indicates the temperature of a body is directly proportional to the average kinetic energy of energy of particles of the body. So the temperature is depends upon temperature. Absolute temperature is directly proportional to its average kinetic energy. Already we discussed in the previous class. This means if the temperature increases, the K of the particle also increases. So here the molecules of the system or body or substance have different forms of energy. Different forms of energy. What are the different forms of energy of molecules in the system or substance or body? What there are four kinds. One is linear kinetic energy, and another one is rotational kinetic energy, vibrational energy, and potential energy. What is linear kinetic energy? Linear kinetic energy means the molecules are moving in straight line paths, and randomly they are in straight line paths. Such particles possesses linear kinetic energy. Next one is rotational kinetic energy. Rotational kinetic energy means here the particles, look here the diagram, look here the figure. So the three particles are there in rotation. While they are rotation, they are in the random motion. So some particles vibrational energy, that means they are vibrating along with moving in the substance, vibrating the back and forth, the to and fro motion of the particles is nothing but vibration. Some of them particles are vibrating in the substance. Some of are potential energy, that means due to their gaps or heights between them, and they should possess potential energy. This means the each and every substance it has different forms of energy. Total different forms of energy is nothing but internal energy. Internal energy means the total energy is called the internal energy of this system. This internal energy in the form of linear kinetic energy, rotational kinetic energy, vibrational energy, and potential energy. Okay, do you understand? So this is the total energy of this system or substance. This is very clear in this substance we can understand from this activity. So why the specific heat different for different substance? This is very important. Why the oil is more, why the oil is lesser specific heat than the water? Because the specific heat is more. Specific heat is more means that means they are when we supply heat energy to the system, the heat energy gives to it will be shared by molecules among the various forms of energy. If you are supplying any energy to the system, in that system the molecules, the energy is sharing in different forms. What are the different forms? Their sharing will vary from substance to substance. In oil, some much of sharing. In water, other different sharing will be takes place. So this rise in temperature is high for a substance if the maximum share of heat energy is utilized for increasing its linear kinetic energy. If the supplying heat energy is utilizing totally, it is utilizing as a linear kinetic energy, then such systems have more specific heat. Such substances are showing more specific heat. That is very important. So, but what about linear rotational kinetic energy and vibrational energy and potential energy? Among the four energies, but if you supply that energy is utilized as the linear kinetic energy, such substances are more specific heat. This is very clear. You should understand. The sharing of heat energy of the system also varies with temperature.